Our story begins with a death, a spectacular demise of a star much larger than our own sun. This wasn't just any death, it was a supernova, a cosmic explosion of unimaginable scale. The supernova ripped the star apart, scattering its enriched guts across the cosmos. This stellar debris, a chaotic cloud of dust and gas, is what we call a nebula. Within this nebula, the seeds of our solar system were sown. Gravity, the architect of the universe, began to exert its influence. The scattered particles, drawn to each other, began to clump together. Over eons, this cloud of dust and gas started to spin, a slow waltz at first, gradually gaining momentum. As the cloud spun faster, it flattened into a disk, much like a spinning ball of pizza dough. At the center of this swirling disk, gravity was pulling most of the material. The immense pressure and heat ignited a fusion reaction, and our sun, a bright, young star, was born. While the sun basked in its newfound glory, the remaining dust and gas in the disk continued swirling. Tiny particles, drawn together by electrostatic forces, began to stick together, forming larger and larger clumps. These clumps, over millions of years, accreted into planetesimals, the building blocks of planets. Closer to the sun, where temperatures were scorching, only rocky materials like iron and silicates could withstand the heat. These materials coalesced to form the inner, rocky planets Mercury, Venus, Earth and Mars. Further out, beyond the frost line, temperatures were frigid. Here, in the cold depths of space, water ice and other volatile compounds could exist in solid form. These icy bodies, along with vast amounts of gas, came together to form the gas giants Jupiter, Saturn, Uranus and Neptune. The early Earth was a far cry from the life-sustaining haven we know today. It was a hot, molten ball of rock, constantly bombarded by asteroids and comets left over from the solar system's formation. These violent collisions generated immense heat, keeping the planet in a molten state. As the bombardment subsided, the Earth began to cool. Heavier elements like iron and nickel sank towards the center, forming the planet's core. Lighter elements like silicon and oxygen rose to the surface, creating a primitive crust. Between the core and the crust lay the mantle, a thick layer of molten rock. This period of intense heat and volcanic activity played a crucial role in shaping the Earth's future. Volcanoes spewed gases from the planet's interior into the atmosphere, while the cooling crust solidified to form the first continents. Around this time, a cataclysmic event occurred that would forever alter the Earth's destiny: the formation of the Moon. The giant impact hypothesis suggests that a Mars-sized object named Theia collided with the young Earth. The impact was so powerful that it ejected a massive amount of debris into space. This debris, caught in Earth's gravitational pull, coalesced over time to form our Moon. The Moon's gravitational influence had a profound impact on the Earth. It stabilized the Earth's rotation, which had been wildly wobbling after the impact, and created the tides. More importantly, the Moon's gravitational pull tilted the Earth's axis, giving us our seasons. This tilt, along with the Moon's stabilizing influence, created a more stable and hospitable climate, paving the way for the emergence of life in the Earth's primordial oceans. The story of the Moon is inextricably linked to our own, a celestial dance that continues to shape our planet and inspire wonder in our hearts.